Alright guys, so let's do a review for the dosage comp exam that y'all have. Um, so starting back with week 1, let's talk about the rounding rules that we remembered from this week. Biggest thing to remember is that all of your heights, weights, and temperatures should be rounded to the nearest tenth. Weight and temp. Now remember that you also need to look at your conversion sheet because there may be some conversions on the test. So make sure you remember that. So let's run through how we would solve one of those real quick. Okay. Okay, 20 milliliters, and we're going to convert it to teaspoons. So from our conversion sheet, we remember that 1 teaspoon is 5 milliliters. So setting this up with our dimensional analysis cross, remember order goes on the left, what we have available goes on the right. So 20 milliliters, teaspoon, 5 milliliters. Milliliters cross out. We have teaspoon left, which is what our answer needs to be, so we can multiply across the top and the bottom, which gives us 20 divided by 5, which is going to give us 4 teaspoons. So make sure that you just read up on your conversion sheet. Moving on to week 2, that is going to be our oral and parenteral doses. So let's work a couple of problems. All right, so looking at this, we have an order to give 25 milligrams of this medicine. It's available in 10 milligram tablets, and we want to know how many tablets we're going to give. So remember, we're going to set up our dimensional analysis cross. 25 milligrams on the left because that's our order. And on our right, we have what's available. So 1 tablet over 10 milligrams. Milligrams cross out, tablet left, which is what we need our answer to be in. So we can go ahead and multiply across the top and the bottom, which is going to give us 25 divided by 10, which is going to give us a final answer of 2.5 tablets. So then moving on, let's look at our parenteral doses. All right, so right here we have our order of 20 milligrams and available. It's the medicine with a concentration of 50 milligrams and 3 milliliters. And we want to know how many milliliters we're going to give. So draw our cross. Order goes on the left, so our 20 milligrams goes over here. And then available on the right, so 3 milliliters over 50 milligrams. Milligrams cancel out. Left with milliliters, which is what we need, so we can multiply across the top and the bottom. which should give us 60 divided by 50. Which is going to give us 1.2 milliliters. So remember your rounding rules for this. If it's less than 1 milliliter, you're going to round to the nearest hundredths. And if it's less than 1 milliliter, you're going to round to the nearest tenth. Let's see, let's work out another one. All right, so for this problem, we have an order that's 0.005 milligrams, and available is the medication in 20 micrograms per 2 milliliters. So first thing we notice, orders in milligrams, available in micrograms. So remember, we need to change our order to what we have available. So using King Henry, 1, 2, 3, we're going to move our decimal 3 places to the right, which is going to make this 5 micrograms. So everything matches up, so we can go ahead and solve this. Order goes on the left, and what we have available on the right. So 5 times 2 divided by 10 is going to give us 10 over 10, which is going to be 1 milliliter. And again, your rounding rules for this week. Remember that if it's less than 1 milliliter, you're going to round to the nearest hundredths. And if it's greater than 1 milliliter, you're going to round to the nearest tenth. Looking at things that are dosed in units now. Also in week 1. Week 2, I mean. Alright, so we're going to give 3,200 units of heparin, and we have available a vial of heparin that has a concentration of 10,000 units per 5 milliliter. And we want to know how many milliliters we're going to give. So, same thing as always with our dimensional analysis. $3,200 units on the left, and fill in what we have available on the right. Okay, our units cross out, left with milliliters, which is what we need for our answer, so we can go ahead and do some multiplication across the top and the bottom here. Which is going to give us a total of 1.6 milliliters. Now moving on to week 3 content, this was our IV drips. So drips by gravity, which is drops per minute. Then we have milliliters per hour. And then we have our drips that have to do with units. So remember, our rounding rule for this week was that all of our answers have to be in whole numbers. So let's get started looking at our first problem. All right, so now we have this problem here. So our order is to give 250 milliliters of normal saline over the next 20 minutes. And our tubing, excuse me, has a drop factor of 10 drops per milliliter. And we want to know how many drops per minute we're going to run this infusion at because we have no pumps. So remember, everything from the order goes on the left-hand side. So we have 250 milliliters over 20 minutes. And remember, we're thinking of this as drops over minutes. That way we want our drops on top and minutes on the bottom. So we have our order. Now let's throw in our tubing from our drip factor from our tubing. Milliliters cross out. We have drops on top, minutes on bottom, which is what we need. So we can go ahead and multiply across the top and the bottom. Which is going to give us 125 drops per minute as our answer. All right, so in this problem, we have 480 milliliters of IV fluid that we're going to infuse over the next 2 hours. And we have a drop factor of 20 drops per milliliter, and we want to know what our answer is going to be in drops per minute. So remember, we're going to set this up so everything from our orders on our left-hand side and our drop factor goes there on the right-hand side. Now our milliliters cross out and we're left with drops over an hour, but that's not what our answer needs to be in. So looking at hours, how are we going to get that to minutes? Which the answer that you're thinking of at this point should be, I'm going to convert my hours to minutes. So let's draw our third column, and we know that there are, in 1 hour, there's 60 minutes. Hour crosses out. We have drops over a minute, which is what we need. So at this point, we can start multiplying across the top and across the bottom. Which is going to give us a final answer of 8 drops a minute. Now let's look at this next one. So you may see an answer that looks like, or a question that looks like this. In this case, we have 1,200 milliliters of IV fluid that we need to infuse over 6 hours. And it wants to know what our infusion rate is going to be in milliliters per hour. So let's go ahead and write it down here. 1,200 milliliters for 6 hours. We have milliliters over hours, which is what we need. So all we're going to do is divide. So 1,200 divided by 6 is going to give us 200 milliliters an hour. Right, so in this problem, we have an order to give 750 milliliters over the next 45 minutes. And we want to know how many milliliters per hour we're going to run our infusion for. So, set it up, 750 milliliters over 45 minutes. Well, looking at that, we have milliliters over minutes, not what we need. So how are we going to get our minutes to hours? That's by converting it to an hour. So we know that there's 60 minutes in 1 hour. Minutes cross out. Milliliters over hour, which is what we need. So we can multiply across the top and then the bottom. So we have 750 times 60. Divided by 45, which is going to give us a rate of 1,000 milliliters an hour. Now, last thing that we're going to move on to here to look at is pediatric. For the dosage comp, you only have one pediatric problem, and that's going to deal with determining if an order is safe or not. So that's all we're going to focus on here. All right, so we're looking at this problem. We have an order for 500 milligrams of Tylenol. We have a recommended range of 10 to 15 milligrams per kilogram with a child's weight of 28 pounds, and we want to figure out their minimum dose, maximum dose, and is our order safe? So monitoring. So looking at our minimum dose. Remember with these problems, our weight's going to go first, followed by our weight conversion. So 1 kilogram, 2.2 pounds, and then we're going to plug in our lowest number in our recommended range. Okay, so our pounds cross out, kilograms cross out, which means we have milligrams left, which is what we want, and some multiplication can occur. Now remember, when we're writing answers in milligrams, it's the same thing as our milliliters. Less than 1 milligram, we round to the nearest hundredths. More than 1 milligram, we round to the nearest tenths. So this would make our answer 127.3 milligrams for our minimum dose. And then for our maximum dose, we're going to use our 15 here. So setup is exactly the same. Weight first, then our weight conversion factor, then our 15 milligrams times 1 kilogram. Kilogram and pounds cross out, and then we can start solving. So 28 times 15 divided by 2.2. It's going to give us 190.9 milligrams. So biggest thing, is our ordered dose safe? Well, remember that in order for a dose to be safe, the order that the physician prescribed, which is 500 milligrams in this case, has to fall between our minimum and our maximum. So does 500 milligrams fall within 127.3 and 190.9? The answer is no. So no, our order is not safe. That should be a pretty good overview of everything that is going to be on the dosage comp exam. So hopefully this is helpful for you guys. If you have any questions, feel free to reach out to me, and good luck.